Have you seen the new trailer for Onward? It looks so cool. I'm so excited. Look at the colour. Look at the humour. Look at the moons. Wait a minute, moons? What kind of planet has 2 moons? Okay, if we're going to work out on what planet Onward is set, we're going to need some criteria. We need a planet with presumably liquid water. Otherwise, what else are these mermaids going to be swimming in? We need mountains, so we need a rocky planet, an atmosphere, presumably they have something to breathe, and 2 moons. So my first thought when I was digging into this is Mars. Mars has 2 moons, it's very, very mountainous, and has lots of evidence that at some point in its past it had abundant water on it. Could this movie be set long ago in a galaxy very, very near us? We need to do a bit more digging. Mars' biggest moon, Phobos, is only 11 kilometers wide, but being only 6,000 kilometers away from Mars itself, it is the closest moon to a planet in our solar system, which means it has a really quick orbit. For context, Mars has about the same length of day as Earth has. It's only 37 minutes longer than an Earth day. So it's like a full Earth day plus watching an entire unskippable ad break on live TV. Who even does that these days? But one orbit for Phobos is only 7.5 hours long. So while on Mars the sun and everything rises in the east, Phobos actually rises in the west, crosses over the sky in about 4 hours, sets in the east, and then does that again twice every single day. It's also one of the least reflective things in our solar system, which means it's about 10 times darker than the moon. Even at full moon it'd be really dark. Oh, and the full moon would only last like an hour. And then we have Mars' second smaller moon, which is a bit further away, Deimos. It's still pretty close to Mars though and has an orbital time of about 30 hours. Overall though, because it's so small, its angular size, i.e. the amount of space that something takes up in the sky, is about 10 times smaller than the moon. Phobos, its larger brother, is about 5 times smaller than the moon, about 1% of a degree. Both of these moons, because they're so small, are very irregularly shaped. In fact, they look a bit more like asteroids than they do like moons. Right, so given this information that we now know about Mars' moons regarding their size, shape, orbit, colour, they're looking less and less like these moons in the Onward trailer. We're going to have to travel a bit further afield. Let's find some exoplanets. So how do we find exoplanets? That's planets orbiting other stars. Well, one method is the radial velocity method. This is where we measure the spectrum of the star to detect any wobble that that star might have due to large planets orbiting it. Take our own sun for example. Because of the gravitational pull of Jupiter, not only is Jupiter orbiting around the sun, but the sun is also orbiting a point just outside the edge of the sun itself. If you were an outside observer looking at our sun, what you would see is the light is slightly blue shifted as it wobbles towards you and then red shifted as it wobbles away. The amount of this shift tells you how big the planet is, and the duration tells you how far away that planet is from the sun. This is one of the oldest, most tried and tested methods for discovering exoplanets, and nearly a quarter of the known exoplanets that we have are from using this method. Our nearest star, for example, Proxima Centauri, is about 25 trillion miles away, or 4.2 light years. It has one confirmed and one unconfirmed planet orbiting it, Proxima Centauri B and C. Proxima B is about 1.3 times the size of Earth and orbits really close to this star, like about 20 times closer than the Earth is to our Sun. In fact, because of how close the planet is to its star and how old the star is itself, it's very likely that Proxima B is tidally locked to the star. That means once every orbit, it rotates on its axis, so the same face is facing the star at all times. That means if you lived on this planet, you would have one half of the planet is perpetually in daytime and one half would be plunged into a cold darkness.
Winter is coming.
Proxima Centauri is a faint old star and so doesn't give off as much heat as our sun, for example. What you do have to worry about being so close to the star is that solar wind and all that radiation. If the planet can even hold on to its atmosphere without it being blown off by the solar wind, you might need to worry about your face being burnt off because of the radiation. So maybe not as habitable as we think. Let's go further out. One more recent method of helping us detect exoplanets a lot further away from us is the transit method. This has helped us find hundreds of planets in the past 5 years or so. So unlike the radial velocity method, the transit method doesn't detect the wobble that the planet's causing the star, but the shadow that the planet causes when it passes in front of the star. When a planet transits in front of a star, the brightness of that star will dip ever so slightly until the planet is finished transiting across the star. This very distinctive pattern tells us how big the planet is because of how much it dips, and how far away the planet is because of how long it takes to transit the star. This method, along with amazing observations from the Kepler Observatory, have resulted in hundreds of new exoplanets being added to our list, many of them potentially habitable. Habitable is a word that we use where Goldilocks would say, it's not too hot, not too cold.
All you need is a light jacket.
One such potential planet is Kepler 442b. This planet is about 2.3 times the size of Earth. It is potentially rocky and so therefore quite mountainous, and it's in the habitable zone, which means that if there was water on there, it's likely in liquid form. It has a mean temperature of minus 40 degrees Celsius, which is also minus 40 Fahrenheit. Who knew? This might seem kind of chilly, but at certain points of the day, at certain places on the planet, you have the ingredients for liquid water. This planet is also far enough away from the sun to be rotating on its own axis, so you're likely to have days and nights, rather than just either burning your face off or freezing to death. And maybe, given its size, 2 moons? Who knows? The planet is a good 1200 light years away, so it might take a while for us to potentially make contact and then, ask the aliens how long their days are. So there we have it, my list of potential planets that the movie Onward is set. Are you looking forward to the new Pixar movie? Do you think it could be one of these planets? Let me know in the comment section down below. Anyway, I hope you enjoyed this episode of Science with Steph. If you did, give it a like, share it, and then subscribe if you haven't already. If you want to watch my last episode, you can click here, or if you want to watch the video that the YouTube algorithm thinks you'll enjoy best, you can click down here. Alright, thanks for watching, and I'll see you next time. Alright, bye! Pretty obvious.